Working out formula using percentage composition figures. Now we will find the formula using the given percentage compositions. On page 183. Find the empirical formula of a compound containing 85.7% carbon, 14.3% hydrogen by mass. The relative atomic masses are 1 for hydrogen and 12 for carbon. So we need to find the empirical formula of the compound that contains 85.7% of carbon and 14.3% of hydrogen. Let's suppose that the amount of substance equals 100 grams. Using the percentage, we want to determine the masses in grams of this substance. First, we will find the masses of carbon and hydrogen in order to find the empirical formula. So let's consider that the amount of substance equals to 100 grams. For carbon, we said the amount of the entire substance is 100 grams. So for carbon, it accounts 85.7% out of this 100%. But I want it in grams. How do I do that? 85.7% will give 100%. So in grams, how many grams of carbon will I have? So I just put 100 grams below the 100% and a question mark under 85.7% so that I calculate the amount in grams. So I will simply apply the cross multiplication. I will multiply 85.7 by 100 and the 100% I will multiply it with the question mark. But since there's a question mark, I'll put question mark equals to 85.7 multiplied by 100 divided by 100. Why? Since 100% is alone, there's nothing to multiply it with. So I divided by 100. 100 goes with 100. I crossed them out. And now I'm left with 85.7. So the answer is 85.7 grams. Similarly, for hydrogen, I will apply the same way. So I will get 14.3 grams. So these are the masses of carbon and hydrogen. In this table, I will put the given percentages and the masses I obtained in 100 grams. So for carbon, it's 85.7 grams, and for hydrogen, it's 14.3 grams. Number of moles, as we said, equals to the mass divided by the mass of 1 mole, which is 85.7 over 12 for carbon, which is the relative atomic mass, and for hydrogen, the mass, which is 14.3 divided by 1, which is the relative atomic mass of hydrogen. So these are the answers. As you can see here, 14.3 is double 7.14. So the ratio is 1 to 2. Meaning for 1 atom of carbon, I have 2 atoms of hydrogen. So the empirical formula is C1H2. 1 atom of carbon and 2 atoms of hydrogen.